Dr. Ranjani Parthasarathy is a professor in the Department of Information Science and Technology, Anna University. Her area of specialization is computer architecture and networks. One of her special interests is Indian language technology systems. She is actively involved in research in all the areas and has over 50 publications to her credit. She has about 25 years of experience covering both industry and academics.
Welcome to the UGC lecture series in computer science. This is a series of lectures in computer networks. Today will be the concluding lecture in this series in computer networks. Topic today would be that we would take a complete top-down view of all activity that takes place on the internet. So, this would help us to recap the various protocols that we have looked at and summarize the entire activity that takes place in the network. So, our idea today is to take an application and see how the network performs with respect to that application. The same kind of thing can be used for any application. So, let us just do a quick review of some of the things that we have already covered. This picture now must be familiar to you, and I am sure you can recognize the various elements that are there in this picture. So, we have a network here, another network here, and there is another network of routers out here. So, you can see that in this, say let us say this is an institutional network. So, I have different machines connected say by means of, let us say it is a home access connected by means of a dial-up modem through a switch or a router to various other machines, and this router in turn is connected to many other routers. There is an interconnection of routers here. So, and this route again I have another say an organization is providing some services, which again has a set of networks in here. There is another network out here. There are many servers which are connected to this. There are also some wireless connectivity that can happen. There can also be some antenna based wireless connectivity that can happen. So, you can see that there are different types of networks, physical networks, which are interconnected by means of the means of the routers, so that we have the complete internetworked instance that is available today. So, now let us look at how any data transfer takes place between a node which is located somewhere on one network and another node, say let us say it is a server on some other network. So, now we are looking at this as our sample scenario. So, I am talking about a client somewhere here making a request to a server which is somewhere in this network. Okay, this is the scenario that we are going to kind of look at. So, remember also that encapsulation and decapsulation takes place at every node, at every layer. So, just a quick recap of what happens there. So, from any node, when I am transmitting data to any other node, from the application layer as a source which is giving some message M, this message which is coming from the application layer is sent to the transport layer. So, at the transport layer a header is added HT. Now, HT plus M is given to the network layer, and then we have another header which is added at the network layer HN, and then we have this coming to the link and physical layer where again the header of that particular layer, the link layer, is also added, and this goes to the physical layer, and it is the set of entire data including the headers that is actually transmitted on the physical layer. Now, remember that we refer to it as a message at the application layer, a segment at the transport layer, we refer to it as a datagram at the network layer, and as a frame at the link layer. Now, the data that is coming in here will go to the physical layer, and then if we are talking about a switch where the switching is happening at the link layer, so we talk about traversal of the data through two layers, through the physical layer and the link layer. So, at this link layer the HL, the header here, would be inspected, and based on that action would be taken, and then when it is to be sent on another link, the corresponding header of that link layer will be added and sent over to the physical layer. So, now the data will traverse through this link, and when it reaches the router, at the router we have three layers which are in action: physical layer, link layer, and the network layer. So, when it comes from the physical layer, at the physical from the physical layer it will be passed the link layer. At the link layer header is removed, and then the data is passed to the network layer. So, you have HN plus HT plus M, this is the data that comes to the network layer. Network layer acts based on the information available in this HN, in the header of the network layer, and then correspondingly makes any changes required and passes it on to the correct link. So, it passes it to the link layer. The link layer again will add its header. Similarly, it will pass to the physical layer, and you can see that it will finally reach the destination. At the destination again we have decapsulation taking place, where each layer will remove its header and pass on the data to the previous layer, to the upper layer, and finally you can see that the message M will reach the application. So remember that this is the general activity that is going to take place for any packet that is going from any one node to any other node. So we will keep these two in mind and take a look at one application. The application that we will look at is the most common application. So we look at the web browsing application. So you open up your browser and you type say http://www.google.com and you press enter. So we want to know what will happen from the time you press enter to the time that the page is actually displayed to you. Okay, this is our sample application we will look at. So you can see that if you look at this web browsing application, there are a number of protocols that are actually used. We know that at the application layer you will have the HTTP protocol being used because of web browsing application, and there is one more protocol which will be used, which is the DNS protocol. Now we have already looked at HTTP protocol and the DNS protocol. DNS is our domain name service protocol, so which will take care of transforming your www.google.com to the corresponding IP address. So it has to give you the matching IP address. So that is done by the DNS protocol. So we will have the HTTP and DNS protocols at the application layer. Then at the transport layer we will have the TCP or the UDP protocols being used. Now we will figure out, we will just see how which protocol is used by which application layer protocol. Then at the network layer we will have the IP protocol being used, and at the layer 2 link layer, data link layer, and this thing we will have the MAC protocols being used. Between the IP layer and the MAC protocols we also have the ARP protocol, which is used to map IP addresses to the physical addresses. Okay. So these are the different protocols that will be used at any one end. In addition to this, of course there are many other protocols that will be in action, but we will just take a look at what is happening at the end machines with respect to these different protocols. So, so this is our scenario now. So this is the machine which is making the request. Let us assume that this is the machine making the request and the server is located somewhere here on this network. So what is actually going to happen is that the data coming in from here will have to traverse through this entire network, through various routers, and finally reach the destination. I will also assume that we have a local DNS server located here. Okay, so this is our local DNS server. So remember what happens in the DNS protocol. When a request is made by a client to the local DNS server, the local DNS server will check whether the information is available with it. If the information is available in the local DNS server, it will give the information, will give the reply back, that is the mapping, the matching IP address for the given domain name will be given by the local DNS server back to the machine. So that is the first step that is going to happen in our series of activities for this particular request. So we will take a look at how that happens first. Okay. So the first thing that is going to happen is we need to get information, the DNS information. So a request has to be sent from this application to the local DNS server. So now let me assume that this is our local DNS server. This is the actual client which is making the request. So now the moment you specify www.google.com, the first application that is actually invoked is the DNS application. So your browser will actually make a request to the DNS client which is running on your machine, and the DNS client now takes charge and is going to contact the DNS server. So it is going to contact the local DNS server. So also remember that at each node we go through all these different 5 layers, and at the routers we only go through the 3 layers, physical link and network layer. Okay, so let us look at how the data will flow in the case in the first request that is being sent, which is the DNS request. So how data will flow is like this. You can see the data flowing there. Okay, so you can see what happened. So DNS request which originated at the application layer here, that is the application we are talking about here is the DNS client which is running on your machine. So the DNS request originated here, went through the transport layer, network layer, link layer and physical layer, traversed the physical layer up to the switch. At the switch again it went through the link layer, network layer, switching was done, then again through the link layer, physical layer, reaches the physical layer of the local DNS server, and from here through the link layer, network layer, transport layer, it reaches the application layer. So we can see that this is what has happened. So now note that we are considering case of DNS running over the UDP protocol. Remember our UDP protocol, the user datagram protocol, it is a connectionless protocol. So what it does is, as soon as it gets a request from DNS, any packet is received from a higher layer protocol is just taken by the UDP and just passed over to the network layer after it adds its header. there is no connection setup or any such thing that happens here. Okay, so which is what we have seen here. So the moment the DNS request is given, it is just passed through these various layers and it is sent to the local DNS server. So now we will assume that the local DNS server has information for this request, that is, it already has it in its cache, in which case the next step that is going to happen is that the local DNS server will send a reply back to the client which requested it. So let us look at what happens there. So next step is DNS in the reply part of the DNS information getting process. So now here it will originate here from the DNS reply, and you can see that it flows back to the DNS to the client which requested it. So now reply started from here, and you can again see it going through all the different layers. Remember, there is an encapsulation taking place at each of these layers. Headers are added as you go through these various layers, and then again decapsulation takes place here, again encapsulation takes place here, right, and then again a set of decapsulation happens before and finally the reply is delivered to the application. The application, remember, here is the DNS client which has requested the application. Okay. So at the end of this process, what has actually happened is that we have received the DNS reply. So we have got the IP address to which the HTTP request needs to be sent. Okay. So this is a process that takes place even before your HTTP request is sent. Okay. Now a little bit more on DNS before we move on to the HTTP request itself. So what if the local DNS did not have the record? So this is something which could have happened, right? That is, our assumption here was the local DNS server had the record and therefore it was able to give back the information. Now what if it did not have that information? So remember what would happen then? We will have to make use of recursive or iterative querying techniques until you reach the authoritative server. That is, local DNS server would have sent the information, the request, to the root server, and from the root server you would have used either a recursive process or an iterative querying process, and we would have moved on to the authoritative server. Remember, the authoritative server is the one which will have the authoritative record, the A record for that particular for the particular domain name. So it receives, so that would give back the IP address, the record which contains the IP address. So once that comes to the local DNS server, then the local DNS server will send it to this client which requested it. Again, remember that for this recursive process or the iterative querying process, you again have a set of encapsulation, decapsulations taking place. You go through all the layers which are there in the network for every request that is being sent. That is, when the request goes from the local DNS server to the root server, let us say, again you have this whole process taking place, going through various routers before it reaches the root server. And then let's assume an iterative querying. So from the root server, I get back a reply to the local DNS server. Now based on the next server information available to me, again the next server will be contacted by the local DNS server, which means again we have a series of packets being sent, right. So this process will continue for as many number of servers that you need to contact until the authoritative server is reached. So once the authoritative server is reached, then you get back the information to the local DNS server, and then the local DNS server gives the information to the client which requested. You can see that there is a lot of activity that takes place even before you have even sent the HTTP request. And remember, all this takes place really fast. So you can look at the speed at which all the different activities are actually taking place. Okay. So, so this is something that we need to remember. Now the next thing that will happen is the HTTP request being sent. So before that, we will just take a short break and then we will come back and continue. Welcome back after the break. So we just looked at how information flows when the DNS request is being made. Now that we have got the DNS information, let us look at how the HTTP request now will be processed by the application. Okay. Now by the network. Now let us look at what happens here. So the application now in charge is the HTTP application, right. That is, it has got the reply from the DNS client. So it knows the IP address to which the connection is to be made. So HTTP now passes that information to the transport layer, right, and which is the transport layer that we have here. Let us see, TCP transport layer protocol. The protocol we have here is the TCP protocol. Now remember that TCP is a connection oriented protocol. So what would TCP do now? It now has to establish a connection with the end machine, okay, and then it will be able to send the request. So HTTP first sends the request to TCP, and now it is TCP's job to establish the end-to-end connection. So, let us look at how that happens. So, TCP's connection establishment process, if you remember, is a three-way handshake. There are three steps that take place there. The first is the SYN packet being sent. You can see that the SYN packet now goes through the network. It goes through two routers that I have shown over here, and then finally reaches the server. Okay, so if we just trace the path, so from the transport layer, the TCP layer, a SYN packet is sent, goes through the various IP layer, link layer, physical layer, and so on, reaches the local router. From this local, through the local router again, it will go through the link layer, network layer, and so on, comes down to the physical layer. Depending on the network address, it is sent to the corresponding router, or maybe a series of intermediate routers, but what I have shown here is just two routers. But you can extend the same concept and say that if there are multiple routers that it has to go through, the same activity of going through the physical layer, link layer, network layer will take place at each of the routers. So, it goes through these different layers, and then finally, when it reaches the destination network, it goes to the destination node at the physical layer, link layer, network layer, reaches the transport layer. So, the transport layer here, let us say the application, the web server here has already opened up a connection to this and waiting for requests from the clients to come. So, when it receives the SYN packet, you can see that this will respond by giving what is called as a SYN plus ACK. This is our second step of the TCP connection establishment process. Now, you can see that now the SYN plus ACK packet will now flow in the reverse direction, that is from the server it will go to the client. So, let us just take a look at what is happening there. So, you can see how the packet will flow, goes through these different layers, right, through the physical layer and back to the transport layer. The SYN plus ACK has come over here. Okay. So, this is our step 2 of the TCP connection establishment process. So, again you can see same kind of activity taking place at every intermediate node. Third step now will be the ACK being sent, right. So, the ACK now is sent from the client to the server. So, this finishes up the connection establishment process. Our three-way handshake consisting of a SYN going from client to server, then we had a SYN plus ACK coming from the server to the client, and the client again giving back an ACK to the SYN, indicating that the two-way communication is now set up. Once this two-way communication has been set up, now we are ready to send the HTTP request to the server. So, to send this HTTP request to the server, look at now what happens. So, now already the HTTP request is available at the transport layer because the application had made the request. So, that request now is sent by the TCP protocol to the TCP protocol on this side, and this TCP protocol on this side will deliver it to the application. So, let us look at how that happens. So, this is our next step, HTTP request flowing down through the network, through the routers and coming to the end machine and finally to the end application. So, we have come to the end application, HTTP request has been received. So, what is the information that would be there in this HTTP request? As per the HTTP protocol, it would probably be a GET method indicating that you are requesting to get the particular page. The page that we were looking at is say www.google.com. So, now google.com server has received this request. So, what is it expected to do? It passes the request and it sends back a reply. So, now the next step therefore will be the reply coming from the server. So, HTTP reply is formed at the application layer here, that is that by the web server, and now this gives back the reply. So, you can see that reply again flows back through the network, right, goes again through the different routers and then through the final link back to the client which requested it. Okay. So, with this what would have happened is the main page of google.com would have been received with indication of different objects which are there in that particular page. Okay. So, the first main page has been received. Now, if there are multiple objects which are there in the HTTP reply, so for each of these replies again requests have to be sent and replies will be obtained. So, once all the replies are obtained, then your page is displayed to you, or of course, the page could be displayed to you even before that, and as the replies are obtained, the page will be filled with all the information. Okay. So, you can see what is happening here. So, we will have more HTTP requests and responses. So, one request and response per object. So, if there are 10 objects, so you can see that there will be 10 more requests generated and 10 more responses that will be received. And again remember, we have two modes of operation in HTTP protocol, which is the pipeline mode of operation and the non-pipeline mode of operation. So, if it was the pipeline mode of operation, we would be sending them back to back. If it was a non-pipeline mode of operation, we would wait for every HTTP response to be received before sending the next HTTP request. So, you can see that there will be number of RTTs that it would take up before the actual page can be finally displayed to you. Okay. So, if you look at other, now what we have looked at is just what is happening at the end machines. Now, we have assumed a number of things in terms of the background activity. So, let us just take a quick look at the different background activity that would be required. So, in terms of routing protocols, okay, look at what are the different things that would actually be done. There would be some interior routing protocols that would be running on the network. There will also be some exterior routing protocols that will be running on the network. That is, we talk about inter-domain and intra-domain routing protocols. Our RIP and OSPF would be our intra-domain routing protocols. RIP, remember, it stands for Routing Information Protocol. OSPF stands for Open Shortest Path First, and the exterior protocol could be some border gateway protocol that could be used. Now, these are routing protocols that would be running, exchanging information between the different routers, so that the routers are able to set up the routing table. Now, what we had assumed now was that these routing tables are contacted by the or consulted by the routing table by the routers to forward the packets correctly. But in order to do that, you would have number of RIP and OSPF packets that would be running in each of the networks, this information being exchanged between the different routers that are there in the network. Okay. So, this is something that is a background activity that would be taking place. Another background activity would be the DHCP protocol, which would be at the end machines trying to contact a DHCP server which is located on their networks to obtain the IP address. So, our assumption here was that the client knew its IP address and it uses that IP address to establish the connection, but actually it has to first get the IP address. For that, it would have used a DHCP protocol. So, it would have sent the DHCP protocol to the DHCP server which is located on its machine, on its network, and from that it would have obtained the IP address. This is another background activity that would take place. A third background activity that would have taken place is ARP. Okay. So, remember ARP, the address resolution protocol. ARP is used to map IP addresses to physical addresses. Now, in the examples that we looked at, we saw that from the network layer it is just sent to the data link layer. Now, when it is sent to the data link layer then takes care of passing it to the correct machine on the other side. So, now if you take for instance this picture that we have here, if you look at this router sending data to this node. Now, look, or for instance here we are looking at, let me just go back one step. So, here this router is sending information to this node. So, how did so you can see that the data came from this network layer to this link layer. So, and the link layer had to know the link layer address before it could send it to the correct machine. So, it is here. So, if I assume that the physical layer or the layer that I have here is actually an Ethernet network, which means that the MAC layer here is using Ethernet addresses. So, to go from this network, from this node here, which is the router here, to this node which is my end machine, I need to have a mapping between the IP address and the Ethernet address. So, this would have been done by the ARP protocol, which is, remember, running right below the IP layer and just above the Ethernet layer. So, you can see that it is somewhere in between these two, right. So, using this ARP, I would have sent, in fact, before I send the packet here, I would have first sent the ARP request, obtained the ARP response to that. From that, I would have found the physical layer address or the MAC layer address, and then the actual frame would be sent. Okay. In fact, you can see that once I come to the network layer, before it is passed to the link layer, it will wait for some time, do this ARP activity, and then pass on this frame to the link layer, and then finally the HTTP request will be delivered over here. So, you can see that there are multiple such protocols that are actually in action. So, with this kind of setup that we have here, we just saw the HTTP reply also going back. Okay. You can see that when the reply is sent back, again this ARP information will be used, because we have just got the information from a particular router. Now, to send back information to the router again, we need to have the same ARP information. So, at every layer you can see that there will be some ARP information that is used. Whether an ARP request is sent or not depends on whether it is the first request or whether the ARP cache has been updated or not. So, if you have an updated information in the cache, then you don't send again an ARP request, but it goes, there is a consultation of the ARP cache table that will anyway happen. So, you can see therefore that there are number of different protocols that are actually used in addition to the primary ones that we saw at the two ends. So, what we have basically tried to do, if I just summarize what we have been looked at today, is that we have tried to trace the events in a network for any application. In fact, the application we have looked at is the web browsing application. Remember that there is an encapsulation and decapsulation process that takes place at each step. And what we have tried to do is we have tried to visualize the data flow that takes place. Now, if you are able to visualize the data flow in this manner in terms of what is actually happening in the network, just look at how the data actually flows through the various layers and reaches the final destination. At every step, look at if you are able to visualize what happens, then you will have a thorough understanding of how the network actually behaves. So, if you are able to visualize the data flow, as I was saying, you will be able to have a very good understanding of what is happening in the network. So, we just looked at a web browsing application. So, you can even look at a similar application, let us say you are sending email. Okay, you can look at what happens in that case. So, in this case what would happen is, so let us say I am doing a web based mail. So, I am doing a web based mail, what would happen is that again you will have a HTTP protocol that is being invoked for you to first connect to your server. So, for that process you will have a process which is very similar to what we had just now, but beyond that, once your mail that you are sending is sent to the server, your SMTP server, let us say you are sending data from from gmail.com to some yahoo.com. So, from the Gmail server to the Yahoo server, again a connection establishment process will take place, but now at the application layer it will be the SMTP protocol that runs. So, you can see that again from that Google server to the Yahoo server, you will again have a similar set of steps that take place. Again a TCP connection establishment will happen between those two servers. Now, data will flow through that, and then from the Yahoo server it will go, once it reaches the Yahoo server through multiple routers, it reaches the Yahoo server, and then whoever is accessing it from the Yahoo server, so let us say they are also doing a web based access. Again at that end you can see that through the HTTP protocol they will access the server and they will be able to get the content. So, you can see that at every step multiple protocols kind of interact with one another, okay? And once this interaction is understood, the entire idea of how the activities take place in the internet can be very easily understood. So, we have seen how the TCP protocol will work, we have seen how the UDP protocol will work. In fact, in the application example that we took today, we looked at DNS using UDP and we looked at HTTP using TCP. So, you have seen that these two primary transport protocols which are used on the internet behave in two different manners, and we have seen the behavior of both these protocols. So, once these two protocols are understood, your transport layer is well understood. Different application layer protocols we already know. If you look at the network layer protocol similarly, so that will once you have understood the IP protocol working, that is also understood. And we also looked at different MAC layer protocols. So, once we understand the interworking or how all these relate to each other, your understanding of networks becomes very simple. In fact, this is one of the easiest subjects in that sense. Okay. So, now a set of questions for you to quickly review what we have done in today's lecture. Question number 1, which is the first protocol invoked by the web browser as soon as it receives a request from the user? Question number 2, how many RTTs elapse before the HTTP request is sent to the server? RTT is round trip time. Question number 3, for the example considered, how many layers have been traversed in the overall activity? Okay. Here I am looking at different layers. I need you to count all the layers that we have traversed for each and every step that we have looked at. Question number 4, try the same kind of tracing for an email activity. So, I just talked about how it is done for an email activity, but I would like you to do the same kind of tracing for the entire email activity. If you are able to do that, I think your understanding of networks will be well in place. Hope you enjoyed the lecture. Thank you.